So my name is Mohammed Dallag. I am the Principal Petroleum Engineer in Sensia, and also I am the Global Production Domain Expert and the Eastern Hemisphere Special Projects Manager. Workflow: first, data gathering, of course, QC, visualize the data, find the candidate, and final ranking, and also this like 2-3 parts: data integration. We try to integrate it with the Offset, Excel sheet, database, Avalon, Vitrel Studio. We try to do a very good data integration because you need to feed this from a simulation model, from a corporate database, and from a user Excel sheet. And then you have to identify, you have to screen the data, and I will show you this. And by screening, you can see the underperforming wells, and then you can find the workover candidates, and then you rank it, and then you repeat the process to enhance your decision. So that's the workflow. And then when you do the data analytics, we have the Python scripts that can be easily added. This is another webinar to show you how can you add your Python script, how can you visualize that in OFM, and how can you interact with your Python script from within OFM. And then, of course, Vitrel. So we start with the loading, validating, QCing the data, identify those wells with the problem, and then find the opportunities, and then you do the workover like plan, and then you review it, and you provide the feedback from the results back to the system, right? I did that with the corrosion workflow, and that's if you only use machine learning. Machine learning, you use some data to create the model, and then you enhance the model by providing more results, okay? So the idea of the 3 things that we want to know: which well, how we can do our workover, and when should we do it. Of course, as I told you, the data management and QC is a critical step in this. We have 80 advanced and basic QC tools developed for real-time data and for basic data, and I have a document that show you all the data types and all these logics and rules that you should apply in everything. So this is a one snapshot of the project's QC tools. And then you have to visualize your data. And we have in this new OFM 25 a very nice tool to visualize the logs, to visualize the wellbore diagrams, to visualize everything in the dashboard. And then we go through these steps. These are movies to show you when you do the screening. We do it first to find the workover candidates for water encroachment, right? And then I will show this individually. And then you do it for the stimulation, like the frac jobs and acidizing. And then you also do a forecast with reservoir constraints, like when I reach my water cut, or reach my gas oil ratio limit, or I reach my bubble point pressure, when my do nothing scenario will finish. And then you create 2 scenarios: do nothing and then workover scenario. And this is a very critical step. We call it time to die. For ESB, is time to trip. And that's what saved the company 120,000 barrel. Why? Because the production engineer, he doesn't have a reservoir insights, like what's the right bubble point pressure. He just make assumption, right? By doing this with the reservoir insights, we get a very accurate time to trip the well. And then we give it to the production engineer, okay? And then, of course, the giant diagnostic plots, and then the final ranking. So this is the first screen, which is we have the water encroachment map, we have a scatter plot, we have a scatter plot for accumulated oil and water, and we have ranking. At the end, what you will see here, you will see the candidates. So we have 1, 2, 3, 4, 5. These wells, if you do it in sequence, you will optimize your production. And then I can see the trend of each well. So you can see here there is a water breakthrough, clear, and then I have a workover. This one is a constant water oil ratio, so we can understand the performance. And then you have the water encroachment map, and you have the ranking. So this is the first step. It's not the only one here to find the candidates. And then you have this one for stimulation, and this is we're using the formation damage index to see the wells that need to be acidized. And here a table that automatically will rank your wells based on that. Of course, it's based on the reservoir quality and based on other factors. And then you do this high fidelity index, right? And then the second step is to know, after I have these 6 wells, let me ask you a question. If I get these wells, here it means I have to start with this one. So when I rank my wells in the beginning, it showed me that which well you think I should start with. I have 1, 2, 3, 4, 5 wells. Which well you think I should start with to optimize my production? This well, right? Because this well has the highest water encroachment and it have a very high above average oil. If you do work for this, what will happen? It will come here. Wow. So it will be the highest in oil and low in water. This one will come here. This one will come here, will come here. So this is in sequence. If you do those in sequence, you will optimize. But is it the only factor? No. So maybe this well, second one, maybe it will die before this well, right? Then I will lose a lot of production. So this will come now in the beginning, in the first. Now, I mean, at the end, we'll do something called average ranking, right? And we'll give every rank a percentage to get the final ranking. So then I have to do this. I have to do this. I want to see all my wells, the 5 wells, which one will die first based on reservoir constraints. Here I chose the water. I put my water limit. How much? I put the water limit, 90%. And this well, if you leave it without water limit, what? So here you can see how we can find the stimulation candidates was based on the formation damage index model. Here we have 2 scatter plots. One is using the average rate, formation damage index based on the live average rate, and here formation damage index based on average liquid against KH, both against KH. And here we have a report that will sort those with candidates and then show what kind of workover, and also will show you the average rate and will show you all the information needed to do those. And it was very smart. And we integrate that with BibeSim to estimate the bottom hole pressure because they don't have enough surveys. Do you see the value? Okay. And then once you know this, the well will die after 2 years, then it will become the first. Then you have another ranking, which well will die first. So we have 2 rankings. One in how much oil I'm getting. Second in when the well will die. Then I have a workover here created because of type curve. We have a type curve to really estimate this, and it will give you the gain of oil and again when it will stop for the second water cut. Wow. That's why I call it wow. So again, you can create multi workover in the future having all the reservoir constraints, facility constraints, and name it. And that will be done in 1 click. This can be automated with the new OFM. I can put the annotation, I can flag the annotation, and I can tell OFM to start from where, and then do nothing scenario, and create this gain of oil from the type curve, and then continue. And then again, let me just to show you this in a better way. And then you to stop here, another workover, stop here, another workover, to get the last drop of oil from your well. Second is the Chan diagnostic plot. And also I modified Chan, and I have a patent on this. I added the pressure trend analysis and rate trend analysis with Chan. And I'm working in a patent on this that will make it something not only feel the contribution of the water, but feel the reservoir. Of course, you have to confirm this. This is a Chan paper. He was ex-Schlumberger, and he did this something like he collected thousands of wells, and then he tried to find something like dimensionless curves to identify the water encroachment. Of course, here we have the water-oil ratio and the derivative of the water-oil ratio. Of course, the water-oil ratio will give you the encroachment, and this derivative will give you what kind of encroachment. Because if you plot only this one, you will not differentiate between water coning and between a breakthrough, between communication or between channeling. But if you put the derivative, this will distinguish. You can see here, right? I hope I have all. I will see it in the demo. And then you get this one to find also time to breakthrough and also a lot of things, right? This is the final ranking. I will show you now a live demo, which is really, it will have 2 scenarios. Do nothing scenario. If all the engineers go to invocation, that's how much your reservoir will give you. And this is how many wells you will lose. See, within only 5 years, I'm losing from 57 to 20. Why? Because either a water cut issue or gas oil issue or bubble point pressure issue. Now, if you do this, if you do wow, see how much you will save. Wow, almost only 1 well I will lose. So this is the workflow. So we can see this. You have these steps I showed you. I have here like 6 steps, which is a very simple, by the way. This is a basic. So the first one is the which well. And when you click this, again, you will see very nice dashboard that can you can start from day one, and then all of these will be animated. Right? You can see the ranking, the water encroachment map, the hydrocarbon index. Now this is not hydrocarbon index, but it's oil and water rate. This is the cubes. Let's make it fast. So you can see if I click on this well with the shift key, it will show it in the ranking, it will show the location, and it will highlight it here. So it's interactive. Wow. Now if I click on this, again, this is the well, the location, and the well here. So it's interactive, right? And this one also, you can have it different dashboards and different screens, and all will work together. It's a dynamic and interactive. Very good. So now this is my 5 wells I chose, and this is the performance, this is the ranking, and this is here. So that was the first screening. So here you can see how we can find the stimulation candidates was based on the formation damage index model. Here we have 2 scatter plots. One is using the average rate, formation damage index based on the live average rate, and here formation damage index based on average liquid against KH, both against KH. And here we have a report that will sort those wells candidates and then show what kind of workover, and also will show you the average rate, and will show you all the information needed to do the stimulation job, and the reservoir quality and completion quality. Here we have a grid map. It shows the distribution of the formation damage index or the skin damage with those wells, and you can see here the colors show you how much skin damage we have in area wise, and also show you the candidates that we should use to do the workover. Okay. And then we go to second, which is when the well will die. You can see this well will die here. The water cut reach 90%, and it will stop here. If you remove the water cut limit, this will continue. You see, this well will die soon because the increase is a very high. There's a sudden increase in water. Okay, so that's when the well will die. And then you have how, using channel diagnostic plots, how the well is behaving, and you can tell from the plots what kind of problem you have in your well, right? And this is here, is you have to compare it. And so let me get the wells with the logs on them. So give me all the wells with the logs. Show me Zivity and show me gamma ray. You can see now I have my markers here. I have my Zivity, and and of course this one you can edit, right? You can edit, you can change the format. Very, very powerful. And you can add as many logs. You can do it for multi-logs. So I can have it for 1 log, I can have it for multi. So I can say give me completions. I can choose this. Let me choose all. And then I can say I want to see this log, right? You can see I have all the logs, and I have the markers. A very, very powerful thing. I have 7 wells here. I can also have the report to show the data. This is with the current version. So you can see here, I can visualize the data, right? Just reading the last file, you can visualize, you can read the digital data, you can edit. You can see now I select a well, then I can see the logs, and I can see the wellbore diagram. Now we'll come to the last thing, final ranking. Now see the magic. Wow. This is a real data. I have 2 scenarios. The one I showed you the slide, but this is a real data. You can see the first scenario, do nothing scenario. You can see it's written do nothing scenario, and then the workover scenario. This is how many wells I will lose, and this is how many wells I will keep. And this is how much I will get, and this is do nothing, how much I will get. And it will be ranked. Of course, if I add water flooding, then I will have another curve here. If I add any enhanced or recovery, then I have like 3 or 4 scenarios. So this is the final ranking from the database and from your workflow by using well optimization workflow. Thank you so much.